the last video, I showed you what I referred to as vertex form, and that's just a way that you can write a quadratic equation. So let's review that, right? The vertex form looks something like y equals a k x minus d squared plus c. And it's called the vertex form because with your d and c value, that makes up your vertex. Now there's other forms though, right? You have your standard form. And the standard form looks something like y equals ax squared plus bx plus c. And then you have what we call factored form. And that looks like y equals a x minus p x minus q. And so just like linear equations, we have different forms that we can write these in, and we can switch from one form to another. For example, if you want to go from vertex form to standard form, all you have to do is expand. And that should make sense, right? If you multiply this thing out, you get this nice expanded standard form. If you want to go from standard to factored, well, that should be obvious, right? You should factor to get it into factored form. If you want to go from factored form to standard form, well, this is also not obvious, but you should be able to figure it out, right? You're going to expand this, right? And the reason I say that you should be able to figure that out is because if you look at this form, the standard form, it looks like something that's already been multiplied out, right? It's already been expanded. It's not factored in any way. Whereas both your vertex and factored form, they look like they're kind of factored. Like the factored form is obviously factored, and the vertex form kind of does too, because you have a bracket squared. It's just that there's this little term on the end that's added. So the only thing here that you might struggle to figure out how to do is go from standard to vertex. And there's a special process for that, and it's called completing the square. If you haven't heard that before, just hang on and we'll do that one at the end. But if you know how to do all this other stuff and you just want to see how to complete the square, skip to the end of the video, and I think we might have another video exclusively on that as well. To start, let's do an example where we try to go from factored form to standard form. Kind of told you how to do it already, right? I said we just have to expand, right? Whenever you want to get to standard form, no matter what you have, all you got to do is multiply it out, right? You just got to expand what you have, and you'll get to standard form, right? That's the easiest one to get, in my opinion. So factored form, let's say you have y equals 2 x minus 1 times x plus 3. I want that in standard form, so I'm just going to expand it, right? I'll start by foiling these brackets. X times x is x squared, x times 3 is 3x, negative 1 times x is negative x, negative 1 times 3 is negative 3. You can simplify that, right? X squared, 3x minus x is plus 2x minus 3, and then distribute the 2 into the bracket. So you'll have 2x squared plus 4x minus 6. And that's it. Now, if you want to go from standard form, which is what we now have, back to factored form, we can do that, right? Because now this is standard. And I want to go to factored. All you have to do is factor this. So you have to recall some of that work we did with factoring, right? You don't want to forget all that stuff we did when it came to factoring. So what do? Well, we look for a common factor first, right? That's always the first thing you want to do, is common factor first. So it looks like there's a common factor of a 2. If you take out a 2, you'll be left with x squared plus 2x minus 3. Okay, now we have to factor the inside. The inside is just a simple trinomial, right? Because there's a 1 on the front of that x. So you look for two numbers that multiply to negative 3 and add to 2, right? Two numbers that multiply to your last number and add to your middle number. What are those numbers going to be? So what multiplies to 3 and adds to 2? Well, I think 3 and minus 1, right? Because 3 times negative 1 is negative 3, and 3 plus negative 1 gives you 2, right? So plus 3 minus 1. Yeah, I think that's right. And that's exactly what we started with in the last question, right? So this would be your factored form. So already we know how to go from factored form to standard form and standard form to factored form. So we're halfway there, right? We're halfway done all the possibilities. Let's look at another example. What if I want to go from vertex to standard? So again, it's just a matter of expanding, right? So let's do y equals 2 x minus 3 squared plus 1. That's my vertex form. I want to put it into standard, so I'm going to start by changing the way this is written. I'm going to write it as x minus 3 times x minus 3 plus 1. And then you can FOIL that, right? You can say it's x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is also negative 3x, negative 3 times negative 3 is plus 9. You can simplify that, right? X squared minus 6x plus 9 plus 1. Bring in that 2. 2x squared minus 12x plus 18 plus 1. Don't forget your plus 1. Collect like terms now. 2x squared minus 12x plus 19. Now you have it in standard form. Now, if you're paying attention during this process, you'll see that some interesting things happened, right? Like, if you're just paying attention to this part, that becomes, well, this, obviously, which we multiply out to this, and then simplifies to this. If you went backwards in this process, like if you started with this thing, you could identify this as a perfect square trinomial. And the reason it's a perfect square trinomial is because when you factor it, you get two brackets that are the same, and you can write it as that bracket squared. Now, this is not a perfect square trinomial, but this is. And that's why when we go the opposite direction, when we go from standard to vertex, the process is called completing the square, because we're turning this thing into a perfect square trinomial, right? This is very close to being a perfect square trinomial. The only problem is that there's this extra 1, right? It should be 18, but it's 19. So we have to get rid of that 1. Once you get rid of it, you now have perfect square trinomial. You can put it into vertex form. So let me show you what I'm actually talking about here. This might make a little bit more sense. Let's start, and so again, we're going to say that we're going from standard to vertex, and we'll use the same one, right? I'll say we have y equals 2x squared minus 12x plus 19. This is standard form. I want it in vertex. Now, it's a lot easier to do what we just did before than to do what I'm about to do, because there are certain steps you have to remember, right? To do this, the process is called completing the square. Okay, so what do? The first thing you do is you factor out the number in front of your x, the 2, but you only factor it out of your first two terms. And it doesn't matter if it goes into them both nicely. It's going to work here, it doesn't always. You might get a fraction here, and that's okay, right? You still have to do it. So 2x squared minus 6x plus 19. Okay? So first you want that x squared to be by itself by taking out the 2. Next, what we do is we start writing it the same way. Then we pause, and I'm going to introduce a new number, right? Because this inside here, I want it to become a perfect square trinomial. So I have to add a number. What number do I add? Well, if you remember how perfect square trinomials work, there's a way you can figure this out. What you do is you take this number, negative 6, you divide it by 2, and then you square it. What's that equal to? Well, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So the number I add is 9. This here is now a perfect square trinomial. Now, the problem is, though, you're not allowed to just add numbers willy-nilly wherever you want. So if you add 9, you also got to subtract 9. And then you still have a 19 here. Now, for the next step, I have to get rid of that negative 9 so that I just have that trinomial. And I'm going to do that by bringing it outside the bracket. Issue being, though, that when I remove it from the bracket, it's not just negative 9 anymore. Because when it was in the bracket, it was actually multiplied by 2. Right? Because everything in the bracket is being multiplied by 2. So when I take it out, bring it to the outside, I have to bring that 2 with it. So it's minus 9 times 2. And then my plus 19 is, of course, still there on the end. Okay, so we're almost there. What you can do next, if you want, is you can simplify the outside first before we worry about the inside. So just leave that the same. Negative 9 times 2 is negative 18. Negative 18 plus 19 is plus 1. So I'm almost there. All I have to do now is factor this inside. If you want to think of it like you're actually factoring a trinomial, you can say, what are two numbers that multiply to 9 and add to negative 6? And of course you get negative 3 and negative 3. But you don't even have to think about that, because we designed this trinomial through this process to be a perfect square trinomial, meaning that the two numbers will be the same. And if you're not sure what the numbers are, well, just take the square root of 9, or take half of -6, right? Or go back here. We did -6 divided by 2 squared to get 9. Just look at the number inside the brackets. -6/2 is -3, right? So the number we're going to have is just half of this middle number. That might be the easiest way to remember it, right? Or you can just factor it like you normally would, up to you. But in the end, we get x minus 3 times another x minus 3. So I'm just going to put x minus 3 squared plus 1. So we've artificially created this perfect square trinomial to factor, so it factors nicely like this. And then you have this 1 on the end that's straggling behind, right? You're always going to have that extra number, or you usually will have that extra number on the end. And this is your vertex form now. That is what we call completing the square. That's how you do it.